Thank you so much for joining this lesson. We're going to look at a question in the Kcse 2017. That is a question in section 2, number 18, transformations. So make sure you follow keenly as we handle this question. Remember to subscribe to this platform and to also share the link with your friends. So the question is here. So matrices and transformations. Remember, our consultation line means 0704 153366. The question says that the vertices of a rectangle ABCDR A02, B04, C44, and D42. The vertices of its image and a transformation TR A prime 02, B prime 04, C prime 84, and D prime 82. Part A, Roman 1. On the grid provided, draw the rectangle ABCD and its image A prime, B prime, C prime, D prime, and a T. So let's begin there by drawing there to show the triangle together with the image. This one is the vertical axis, otherwise the y-axis. Then now we can come up with the x-axis at this point. Yeah, x-axis that way. Then now we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. Then have -1, -2, -3, -4, -5, then -1, -2, -3. Yeah, such a thing. Now we can come up with the two rectangles. 0, 2. 0, 2, this is A. Then B is a 0, 4. 0, 4, that is B. Then we can talk of 4, 4 and 4, 2. So 4, 4, the coordinate will be found here. That's our C. And 4, 2, which is our D. But let me join the triangle, the rectangle first. This is the first one now. So the rectangle is here. To subscribe to this platform and also to share the link with friends. Yes, now we have the first rectangle. Then the second one, the coordinates of A are still remaining together with the coordinates of B. Therefore, B prime is at the same point, A prime at the same point. But now C and D, C is going to 8, 4. 8, 4. This is where C prime is. Then we have D prime at this point. So now we have to get the new rectangle. So the new rectangle is now enlarged and pushed to where the two new coordinates are. This is now the new rectangle. Remember, the new rectangle beginning from the y-axis all the way to where C prime and D prime is. So now we have the triangle, the rectangle and its image. Now look at the first question here. Describe fully the transformation T. So what has transformed the triangle, the rectangle, into the new rectangle? And you can see that the rectangle has been elongated. In other words, it has been enlarged in one way towards the right, that is horizontally. So there is a certain enlargement following this line, such a direction, you see? So it has just been stretched, or rather, an enlargement following one direction. So we call it a stretch towards the right. So we see that it is a stretch. Now, such an enlargement is called a stretch, and there is how we describe a stretch. So a stretch is described by first mentioning that it is a stretch. Then we give what we call the stretch factor, or rather the scale factor of the stretch. The scale factor of the stretch. The scale factor of the stretch. So at this point now, we have to consider from the new B to the new C divided by BC originally. So let's consider these two lengths. From B prime to C prime, I can see 8 units. And from the original B to the original C, there were only 4 units. So I'm seeing 2 as the scale factor. So the scale factor of this stretch is a 2. Then the other thing to mention is what we call the invariant line. So when you look at the direction is perpendicular to the vertical axis. Perpendicular to the vertical axis. So vertical axis, which is called y-axis, line y-axis. Another name for line y-axis is line x equals to 0, is the invariant line now. It is invariant. So during a stretch, the direction of stretching is usually perpendicular to the invariant line. So considering the direction of the stretching, this direction is perpendicular to the vertical axis. Remember, this should not be confused with a shear. If it was a shear, the direction of shear is usually parallel to the invariant line. So during a shear, direction is parallel to invariant line. During a stretch, like our case here, direction is perpendicular to invariant line. So it is easy for us to identify the invariant line. Look at part 3 of this question. We are trying to determine the matrix of the transformation. The matrix of the transformation T can be given by, remember during a stretch, when the y-axis is invariant, matrix is usually given by K0, 0, 1. In this case, where K is the scale factor. The scale factor of the stretch. Therefore, we can just adopt directly, and because we have determined the scale factor up there, we just fix it here. Instead of the general matrix, now we have a specific matrix for the above transformation. Alternatively, because we have image and the object, we can say that matrix of transformation multiplied by object should give us image. Therefore, a known matrix A, B, C, D multiplied by the coordinates of the object. So allow me pick the coordinates which are going to change, and that is CD. Therefore, CD can be 4, 4 and 4, 2. This one is the same as C prime, because they're supposed to give us the image, whereby we are having now 8, 4 and 8, 2, that way. I hope I'm picking the right things. Yeah, sure, that way. So now we can find these unknowns, row times column, to get the first element here. So A times 4, we get 4A, plus B times 4, 4B, equals to 8. This is the first equation. Then we can also get another equation involving A and B, whereby we say A, when we multiply by the next column now, 4A plus 2B, this one should give us the element at this point, which is still 8. So solving these two equations simultaneously will give us A and B. Let's solve by elimination, whereby 4A by 4A, that one is eliminated. 2B, 4B minus 2B is 2B. This is equal to 0. So the value of B is 0. When we get the value of B, we can still get the value of A by saying 4A, according to equation 1, plus 4 to 0 equals to 8. So 4A equals to 8, and the value of A becomes 2. So we have A as 2 and B as 0. Again, we can form a pair of simultaneous equations, but now having C and D. Therefore, 4A, 4 by C, that is, plus 4 by D. I'm using the row with CD and the first column here. So 4C and 4D. This one should give us 4. That is 1. Another equation, we can use the same row and the last column here, whereby 4C plus 2D should give us the element at this point, which is at 2. Yeah, that way. Again, by elimination, 4C by 4C, so that we have a 2D equals to 2, and the value of D is now narrowed down to exactly 1. If the value of D is 1, we can now find the value of C. So 4C plus 4 by D, which is 1, equals to 4. You know, when 4 is taken to the other side, it will be subtracted, and 4C will be equal to 0, so that the value of C is also 0. Therefore, with those values that way, we can see A is 2 and B is 0. D is 1 and C is 0. So we can now combine that matrix and have 2, 0, 0, 1. Just like the way we have done it here directly. So a student can still follow such a working. Yeah, let's look at the final part of the same question here. On the same grid as in A, draw the image of rectangle ABCD and a shear with the line x equals to -2 invariant. Then the coordinates of A will be 0, 2 and A prime 0, 0. Original A 0, 2 and A prime comes here. So A prime comes here. When we talk about invariant line, let me first draw it. Line x equals to 2 invariant. X equals to -2 invariant. Let me draw the invariant line first. X equals to -2. That is the invariant line. Now, what we are supposed to know is that during a shear, the points in one line will move towards a certain direction. Therefore, if along the line which is having A and B, we have A moving by 2 units, then B will also move by 2 units, and B prime will come here. Where there was A now, we will have our B there. So B double prime will come there. And remember, the points along CD are also supposed to move in a direction same as the direction which has been moved. So they will move in direction like this. But now that we have invariant lines, now that we have the invariant line, then something that we are supposed to know is that the area will not change. During a shear, area is invariant. And because area is invariant, then these coordinates, whereby there is C and D, we also have to cause a certain movement such that we get what we call a parallelogram whose area is the same. A parallelogram whose area is the same as that of the rectangle that we were having. So we will have now D moving downwards to a point like -4. So this one will have to move to -4 here. That is the second image. Then C will just be up there. C will just be up there, double prime. This way, we are ensuring that when A is connected to D, we are getting a parallelogram, and now then we can link them to the invariant line like that. We can link them to the invariant line, you see. So this one can be connected to A, then linked to the invariant line that way. So we can link them to the invariant line such that these two lines remain parallel to one another, and these two, AB and CD, also remain parallel. So we are getting what we call, sorry, think because area is invariant, sorry for that, because area is invariant, there is something I have to make you aware here. Because area is invariant, then C and D are moving down along the same line. So D will be coming here and C up here. Yeah, C up there. So now we can join. And now join. We join C, D and A. We connect them to invariant line that way. So it should be directed to invariant line. We also do the same for C and A. So C and A direct, then to the invariant line that way. So now we can have the rectangle becoming a parallelogram that way. But you will discover that the area has not changed. So we are following the invariant line x equals to -2. Line x equals to -2. So we have to ensure that once we connect the invariant line to the coordinates which we have been given already, we should get what we are calling now a parallelogram. This line and this one are parallel. This one is also parallel to this one. And the area is invariant. So what you should ensure is that during what we call a shear, area is invariant. area is invariant. So that is it. Thank you so much for following. Subscribe and share.